Okay, welcome guys. It's my honor to speak here and I'm very glad to share my topic with you. Then today I'd like to talk something about serverless computing. This, this is full contract with our group we're talking about. First of all, what is cloud computing? Cloud computing is a kind of distributed computing, which means that huge data computing processing program is accomplished into countless small programs, so the network cloud, and then processed and analyzed through the system composed of multi-service. So this is an example of serverless. This picture shows an analogy. To attend a remote conference, you either rent a car or hire a taxi cab to get from the airport to your hotel. Car rental is like server computing, where you must wait in line, sign in a contract, reserve the car for your whole stay, no matter how much you use it. Um, drive the car yourself, navigate to the hotel, pay for parking, and fill it with fuel before returning it. The taxi is like serverless computing, where you simply need to give the hotel name and pay for the ride. The taxi service provides a trail drivers who navigates it, changes for the ride, and fills the gas tank. Taxis simplify transportation as you don't need to know how to operate a car to get to the hotel. Moreover, taxi gets higher utilization than rental cars, which lower costs from the taxi company. Depending on the length of the conference, the cost of car rental, the cost of parking, the cost of gas, and so on. Taxis are not only easier, they might even be cheaper. The beauty of serverless computing is that it provides much more than servers, yet results in cloud bills that are often much lower. Included the price is redundancy for availability, monitoring, logging, and automatic scaling, all of which we need is to be provided separately in a serverless context. We believe that as organizations use serverless more, they will be able to predict their cost based on a history, similar to the way they do for others pay-as-you-go service like electricity. So let's back to now. What is serverless today? Nowadays, some serverless environment can run arbitrary code, each for a specific use case. And the serverless product has three basic characteristics of serverless computing: hidden servers, abstraction, pay-as-you-go, cost module, and excellent automatic scaling. Okay, so next one is my teammates will introduce the second part, which is serverless cloud economies.
Okay, so there is one important consideration about the cost of serverless. And first, we need to clarify one question. The cost of running function per minute on serverless cloud is more expensive than serverless. And for example, AWS Lambda could spend an extra 6.5 times in the same scale. But we should notice that this price includes all redundant properties such as availability, monitoring, logging, and automated scaling. And these are charged separately in a serverless context. In fact, we only need to pay for the execution code on serverless. According to the research of Wagner in 2018, the conclusion is we can save 4 to 10 times when moving applications to serverless. So cloud customers choose serverless computing because it allows them to continue to focus on solving problems or businesses specific to their field, rather than on server management or problems in distributed systems. It is more straight in this chart. Customers don't need to pay for the idle capacity now. This is the main economic advantage of serverless pay-as-you-go model. And one last problem is the standard of serverless. Largest and most established cloud providers could promote their complex APIs to resist standardized process. Hopefully, the introduction from smaller providers, open source communities, or academics could remove this prominent hurdle. Now, let's focus on the next phase of cloud computing. The primary target is to provide abstractions that simplify cloud programming. Before we discuss the specific approaches, there are two premises we should know. In the past 10 years, the core skill required in programming changed very little. In the meantime, works for maintaining and running server has changed a lot. Instead of installation or storage of server, we now focus on managing virtualized infrastructures through cloud providers' APIs and by the DevOps movement. Also, we're facing the problem of most cloud programming become distributed systems programming. We need to concern about spatial extent or security threats of data center. This is similar like programming languages update, which releases programmers from the complex CPU operates. Serverless computing hides many details of a distributed system. There are two approaches to implement serverless abstractions based on this article: application-specific and general purpose. The first one is for a particular use case which already exists today, and what we want to promote is a general purpose for broad variety of uses. Amuse we need to compute an average over 10 billion records using weights derived from 1 million categories. We could use application-specific method like AWS Asking a Big Data Query, a tool programmed using SQL to execute queries, or using a framework like Google Cloud Dataflow with two functions for computing weights and sum. The second one is more general for abstraction so that we can use it to solve a wider range of problems. In fact, we don't have a general purpose serverless abstractions offered performant solution to this example currently. It is a good idea to use cloud functions, but as picture shown on the right, with cloud functions provider distribute work across various VM instance without regard to the application's communication patterns, which simplifies auto-scaling but increase network traffic. Therefore, the author suggests that two paths to enhance the cloud functions which could become a general purpose finally. First, hints provided from programmers about how to achieve better performance. We could see precedents in previous compilers like branch prediction, alignment, and fetching hints. Second, and more compellingly, we envision inefficiencies being removed by automatic optimization. Cloud provider needs to observe and infer the location of optimization's pattern. We could see the difference between application-specific and general-purpose serverless abstractions in this figure. For general-purpose serverless, cloud providers only need to enhance the foundation and basic building blocks. Application use cases can be built on top of this structure. And for application-specific serverless, they need to offer more BAAS to meet the greater number of requirements. In general, application-specific serverless will still increase in the next period, but we are expecting for the potential general-purpose serverless abstractions. Only this one could ultimately displace servers to become the default form of cloud programming. So the last part, my teammate will discuss the research challenges.
Well, thank you for my teammates for their wonderful work. It's my honor to end this video presentation by talking about the last part, which is conclusion and prediction.
Based on what my teammates said earlier, we can conclude that serverless computing is both flourishing and evolving. It has overcome the challenge that faced earlier. Its business is growing up to 50% annually and providing high profit for cloud providers. It's now entering a second phase in which its continued growth will be driven by a new value proposition, simplified cloud programming. Serverless raise the level of abstractions of the cloud, adopts pay-as-you-go pricing, and rapidly auto-scales down to zero and up to practically infinite resources. And there are also many real-life evidence to support these conclusions. First of all, we can see one chart for IBM serverless computing. It shows that in the past 2 years, there are 13% of users create more than 100 new applications with serverless computing, which is one great evidence for simplified cloud programming. And here is another introduction of one of the most powerful serverless computing today, AWS Lambda. And in the introductions, it's just basically everything in the conclusions. And nowadays, serverless computing is so advanced, there still remains some challenges for the serverless computing. The first challenge is state management. Cloud functions today allow application to store temporary states locally at each function, which is useful for caching and as working memory for the program. Serverless shared state may be saved in the object storage, but do not provide low latency, low cost, high throughput, and fine-grained access as is possible with serverless computing. So it's one still remain challenge. And the second challenge is security. But we have to say today's serverless computing shifts some security responsibilities from the cloud customer to the cloud providers, which greatly improves security for cloud customers. But serverless computing also can incur great information leakage through network communication because of the fine-grained decomposition of an application and physical distribution of its pieces. So which means that an attacker can easily observe the size and timing of network traffic to inferences about your own private data. And the third challenge is programming language. We mentioned about two challenges basically for the serverless provider, and I think this is one for the programmer, because as we all know right now, nowadays serverless computing use pay-as-you-go pricing, which means that how to program to take up less memory and run less time is a major future issue, and it requires programmers to be more skillful and more knowledgeable so that they can choose the more suitable programming language and the more suitable code structure that can use less memory and run less time to save your money. And the last challenge I want to mention is hardware. Nowadays, the x86 microprocessors that dominate the cloud are barely improving its performance. In 1917, program latency improved only 3%, a trend that, if continue, imply that performance won't double for the next 20 years. So nowadays, there are other hardware like GPUs perform faster while facing specific program like machine learning. So maybe the provider can use GPU and some other hardware for the specific program. Last but not least, I want to mention some prediction for the future serverless computing. First of all, serverless cloud computing will decline as serverless computing overcome its current limitation. And second, we expect new general purpose serverless abstractions to support just about any use case, which means that the new serverless computing, they will support state management as well as optimization, either user suggested or automatically, to achieve efficiency comparable or maybe better than those server computings. And the third prediction is that the cost of the server computing will keep reduced as serverless evolves. I think it's just pretty obvious, so I'm not going to explain it further. And the last one is we predict machine learning will play a critical role in serverless implementations because machine learning can help decide where to run code, where to keep state, where to start up new execution environment, and how to cost low while meeting performance objectives. And it can also automatically cutting up large program into pieces that can run in separate cloud functions. And actually, nowadays, most powerful serverless computing, AWS, Lambda, have already used a machine learning model to simplify its scaling. So if our prediction become reality, I think in the future, serverless computing will replace server computing, just like nowadays PCs are basically replaced by the smartphones.
Okay, thank you. That's our video presentation. I hope you guys can have a much more deeper understanding about serverless computing after viewing. Thank you.